A statement from Neil deGrasse Tyson. What makes Proxima B fascinating is that it is an Earth-like planet circling the nearest star to the Sun. The James Webb Telescope has now taken the clearest picture ever of a planet, so like Earth that researchers can wonder if Proxima B is somewhere around 4 light years from us, and could be the first exoplanet that we people investigate with tests. After the stunning news about this planet, specialists are building numerous spaceships to actually look at who lives on Proxima B and whether these creatures are agreeable. Proxima B is an exception among exoplanets. This planet is just somewhat more than 4 light years from us, making it one of the nearest heavenly bodies in the universe that isn't part of our planetary system. The Proxima Centauri system has been confusing researchers for quite a long time. For many years, Alpha Centauri was thought to be our nearest heavenly neighbor. However, then surprises kept happening. First, researchers figured out that Alpha Centauri is certainly not an ordinary star at all. It is a double star. Years and years after that, this strange system in our local cosmic area astonished us once more. Modern cosmologists investigating space with truly improving telescopes again found oddities in the Alpha Centauri system that surprised them. Finally, scientists tracked down the justification for these irregularities: a third star. However, the third star in the Alpha Centauri system didn't have all the earmarks of being just a quavering of the definitely known star system. The star was, and is, excessively obvious for that, despite the fact that its circle is straightforwardly connected to the other 2 stars. Proxima Centauri meanders far beyond the circle of the other 2 during its movements through the universe. This led researchers to the possibility that the third star could be captured by the gravitational pull of Alpha Centauri A and B, which has captured a third star, and from that point forward, the 3 have been moving in a common dance in the universe. The exoplanet Proxima Centauri B was found in 2016 as one of the main close-to-Earth exoplanets. The find was a sensation. The James Webb Telescope is now uncovering the real essence of Proxima Centauri B. Proxima Centauri B could be the nearest planet to Earth that is inhabited. This is fantastic because we might really visit this world in the not-too-distant future. Proxima Centauri B would certainly be one of our first objectives when we can build interstellar spaceships. However, we have even more intriguing facts about this. First, we should investigate the marvels of this planet, which is viewed as an Earth twin. Proxima Centauri B is somewhat greater than Earth and a piece denser. It has been clearly identified as a rocky planet, and that means that unlike gas planets, it has a solid surface. Throughout Proxima Centauri B's orbit, it circles its star in a very close orbit, with the goal that a year in the world lasts just 11 days. This doesn't sound simple since close to a star it is exceptionally hot, at least in our system. However, in the Proxima Centauri system, it's different. The star is scarcely as glowing as our Sun. This clearly puts Proxima Centauri B in the livable zone of its star. Assuming the planet additionally has water, it could really be an Earth too, with a gentle atmosphere and life. This is precisely where the James Webb Space Telescope comes in, albeit the planet has been known for a long time, and there has been some speculation about its real essence. Our technology could never determine if Proxima Centauri B has an atmosphere and water. The objectives of the Webb mission are obviously to find out these realities, not just regarding Proxima Centauri B, but also with respect to many other exoplanets that are potentially Earth-like and inhabited. Webb can utilize its extraordinary technology to make the primary precise examinations in the atmosphere of far-off planets. To do this, the telescope utilizes a totally new kind of spectrometer technology that works with infrared light rather than light in the visible spectrum. Infrared light beams can also be emitted by extremely far-off or extremely weak celestial bodies, or rather the light shifts into the red spectrum due to the long journey to us. What Hubble, which works solely with visible light, proved unable to do, James Webb can now do effortlessly. Even the slightest signals from far-off stars that have traveled billions of light years are captured by this new super telescope and converted into visible images. In the case of exoplanets, the technology gives us exact data from a planet's environment on a massive scale. Exoplanets are like grains of sand or dust. They are small compared to their stars, and they can't emit their own light. However, they reflect light, and researchers utilize this to find them. Imagine how an exoplanet first absorbs the brightness of its star. Then it blends in with the planet's atmosphere and is reflected from the surface. Every one of the lights that we can see on the planet, and that gives us lovely warmth, is sunlight that has been absorbed and reflected. In only this way, during these cycles, the light from the sun is changed, and Proxima B changes the light from its star. If the light blends in with specific gases in the atmosphere, or even influences the reactions of the gases and warming cycles, it emits a fine but still noticeable light spectrum. This spectrum contains hundreds or even thousands of different light waves, and each gas and every element produces its own distinctive signature within the light spectrum. In plain language, this means that oxygen in the atmosphere of Proxima B produces similar frequencies to oxygen in the atmosphere of Earth, and the same applies to the best water molecules in the atmosphere of a planet, depending upon the quantity of water present. Planet's current circumstance researchers can then reach further determinations about the measures of water in the world's surface, a tenable water world with land masses and life. Would you at any point have imagined that there are other tenable planets in the universe? Or were you one of those individuals who solidly accepted that we are the only ones in the universe and that the Earth is special? To come focus, there won't ever be a planet that precisely looks like Earth. There aren't indeed even two snowflakes that are the very same. However, there are a few planets that are damn like Earth, and Proxima B is one of them. As indicated by science, a genuine super-Earth is a piece greater, a piece hotter, and undeniably heavier than Earth. Such a planet would contain a lot of water and have agreeably disseminated bodies of land. The environment would be mild and equitably warm, and the star would have about twice the life expectancy of our Sun. During this more extended life expectancy of the framework, superhuman advancements could indeed even form, as per transformative analysts. And it's definitively such human advancements that we desire to view as in the universe. Imagine we have a profoundly smart and specialized society somewhere in our cosmic area, which, on top of that, is well-disposed and interested in contact. We could most likely gain some significant experience from such animals. At the moment, this actually seems like far off, but specialists and researchers are working each second to dominate interplanetary and eventually interstellar space. Go to Proxima B in only 20 years. If Yuri Milner, a Russian tycoon and space fan, has his way, spaceships will be traveling to Proxima B in just a couple of years. The first of these scaled-down rockets will only have a camera and some moderate measuring instruments on board. Anyway, the gear ought to be adequate to give us the main genuine photographs from the Proxima framework and finally show us whether Proxima B is occupied by life. Because of a remarkable speed increase innovation, the tests, which are just a few centimeters in size, will go at nearly the speed of light and arrive at Proxima B in a time of under 10 years. We could see the first photographs of an exoplanet as soon as the mid-2030s. We will see the planet's climate in colors for the first time, and it will be a shock to see whether Proxima B is blue, green, and white like our Earth, or earthy brown, dark, or even red. Because of estimations from the best telescopes on Earth, we know that Proxima B most likely has a bound circle around its star. It has a day side and a night side. The day side is most likely excessively hot for life, and it never gets dim there. The night side is continuously dim and most likely freezing. The fascinating thing about this planet is a change zone that extends once all over this planet, and life could be conceivable there. It sounds insane to us that a planet is livable just on a portion of a few thousand kilometers. On one side, it goes either into eternal brilliance and intensity, and in the other direction into murkiness and cold. That wouldn't make the planet a genuine twin of Earth. As we continue looking for other life in space, we should likewise take into consideration other conceivable outcomes of life and types of life that go beyond our past definitions. This obviously raises the astonishing question of whether we would then also have the option to visit Proxima B ourselves. Yes, Numerous researchers are sure that as we keep on propelling the present status of innovation, we can soon build spaceships with motors that can arrive at practically the speed of light. Outings to Proxima B would then likely be conceivable in around 20 years. Anyway, we still don't have the foggiest idea how we will survive issues, for example, weightlessness in the universe or the impacts of inestimable radiation. All hopes in such manner are nailed to the improvement of the twist drive. This should empower travel through the space-time construction of the universe without the requirement for fuel. In hypothesis, the drive, which we all know from sci-fi films like Star Wars, already exists up to this point. Anyway, we have been stymied by the energy issue. But here, too, there is consistent encouraging progress. In 2022, analysts from the USA prevailed with regards to making a smaller than usual twist bubble. This air pocket can extend space-time in such a way that material items, for example, spaceships and individuals, can essentially slip through a crease for movement over huge distances. We would then require barely any time and relatively little fuel. We just must have the option to make such a bubble for a massive scope, and that will cost energy. The arrangement would lie in elective energy, like negative matter or even the secret of dark energy. Assuming the twist drive is fruitful, we in space travel won't just be free of existence. However, spacemen would additionally be liberated from the burdens of inestimable radiation or impacts like time widening. Subscribe now to the feed. We are continually publishing new, thrilling recordings.